All right, so the respiratory system gets oxygen into the blood and carbon dioxide out of the blood, and then the blood moves, the circulatory system moves that blood to where? Throughout the body. One of the major, all the cells, all living cells, right? One of the major body systems that depends on this, and all of them depend on this, but one of the major systems that uses up a lot of that oxygen, and later we'll talk about the sugar, the nutrients, is the muscular system, because it's literally moving everything in us, whether that's smooth or cardiac or skeletal muscle that we've mentioned before. It is moving the entire body and all the fluids inside. So muscular system is very important. It works kind of like the respiratory and circulatory system. They work really, really closely together. The muscular system, specifically the skeletal muscles, works really, really, really closely with the skeletal system. So much so that there's actually a name for it. It's called the musculoskeletal system. Those two are kind of like Siamese twins. They are separate, but they're kind of the same and attached at the same time. All right, so 3 types of muscles. All muscles help something move. You need to remember that. What do muscles do? They help things move. Either they're helping you move, your whole body. They're making, what's your cardiac muscle do? It's moving what? It's moving your blood. Remember, the vessels are the tubes that the blood is flowing through. Or it's helping stop fluids from moving or moving fluids. We'll talk about that when we talk about the digestive system. So the first time, we're going to go over these, and because we've gone over these, I think, twice before, I'm going to go over all 3 and then remove them from the screen, and I want you to take notes from memory, and we'll put this back on the screen if you need help. So pay attention really closely so you can take notes from memory. If you have questions before I remove it from the screen, let me know. So skeletal system helps your body move by moving the skeletal system. So it's muscle moving bone. And the way that the muscle moves the bone, there's a connection. Who knows what that connection between muscles and bones is? Hint. It's right there, your tendon. So you have an Achilles. If you feel on the backside of your leg, right above the heel, like if you flex your calf muscle, you'll feel feels like a tight cable or a tight rope that's pulling up. You can almost kind of grab it. Also, if you'll take your arm and put it slightly bent, you can grab. So you're grabbing right there by your elbow, kind of pull. There's a tight tendon there as well. Those are tendons. It's connecting a muscle to a bone. Because if the muscle and the bone are two different types of structure in your body, they have to be connected by something. And you've probably tasted this if you eat chicken. If you eat chicken and you eat the meat part, like one of the legs or probably one of the legs. If you eat the meat, you got a big old chunk of meat. And it slowly gets thinner and skinnier and skinnier and skinnier until it turns into something that it feels very different as far as texture. It doesn't break apart. It actually is kind of like gummy or feels like plastic or rubber. That is the tendon. That's the tendon. And it's connecting. It's probably not connected to the bone then, maybe. The cooking and frying or whatever may break that connection down. But that is a type of tissue that is connecting. What does a tendon connect? Muscle to bone. Yes, and there's another one we'll talk about, the skeletal system, that connects bone to bone. But this one connects muscle to bone. And then you have your cardiac. We've already talked about what cardiac means. It means what? Guys, cardiac. What does the word cardiac mean? Heart. Yes. And so if it's a cardiac muscle, you know it's something to do with the heart and something to do with moving things. So if you think through that, even if you hadn't learned this before, if you just knew those 2 words, it is definitely helping the blood move throughout your body. And it is, when I say constantly without vacation, what I mean it is beating, like we did the other day with your heart rate, that little test. It is beating consistently. It is not beating constantly. There is a break in between your heartbeats. But yeah, so your blood is not just like flowing like when you turn the spigot on outside. It's not flowing like that water is flowing. It's almost like you turn the spigot on and then off, and then on and then off, and then on and then off. I want you to do something real quick. Take both of your hands, and I want you to squeeze your hands extremely tight whenever I do. Are y'all watching? So squeeze, let go, squeeze, let go, squeeze, let go. Could you do this for 60 seconds straight? Yeah. Could you do this for 10 minutes? No. Could you do this for 13 years? No, but your heart is. You can go and stop. Are your arms hurting a little bit? If you're squeezing hard enough, it was hurting. Your muscle, your cardiac muscle, your heart, has been doing that since before you were born. when you were a few weeks old, your heart started. And even if there was some event where it stopped for like a few seconds or maybe even a few minutes, your heart has been going almost nonstop for 13 to 14 years. For longer than you have been out of your mama's belly. And so the heart helps the blood move without vacation. You go on vacation, you go to sleep, your heart's still beating. You take a nap, you go on an airplane ride to the beach, you drive to the beach, you snooze in a hammock somewhere, you're resting, your heart is not. It is resting, but it's still moving. It's still beating. And then smooth muscle. This is the hardest one, I think, to understand because it's one that we can't see very easily. But your smooth muscle helps your inner organs move materials around your body. One of these things is called, your stomach. When your stomach is moving food from one side of your stomach into the next and then into the intestine, we'll talk about that. That is smooth muscle. You have little valves around your body called sphincters. One of them is your anus. One of them is at the bottom of your stomach before the intestines. One of them is at the bottom of your bladder. Have you guys y'all know when you were younger, you could not hold your pee inside of you, right? When you had a pee, you just went, and you went often, right? That's what diapers are for, right? When you have to go to the bathroom, you don't say, Miss Hurley, oh, never mind, I just went, never mind. Can I call home now? Like, that's not what you do. You can hold it because you have a muscle there that you have learned to tighten and keep tight. You can even hold it when there's a lot of pressure. Have you ever had to hold it when there's a lot of pressure back there? And you have to think all of your concentration, make sure I don't pee myself or poop myself, and you're holding that muscle very, very tight. Y'all understand? That is a smooth muscle. It is keeping or allowing things to move, whatever you need to. So, and another example is when your parents say, hey, we're going on vacation, we're going on a trip, we're going across town, whatever, go to the bathroom now. And you're like, oh, I don't have to go. I don't need to go. I just went like an hour ago. And they make you go anyway. And even though it was not easy, maybe you forced that urine out. That is another example of being able to use those smooth muscles and push things out. So, another, like I said, example is being able to move food throughout your body. Peristalsis. And we'll talk about that when we talk about digestive system. But peristalsis, if I can, it's where your esophagus. Have y'all ever eaten anything upside down, like hanging from monkey bars or something? Try to eat something. Mm-hmm. Can you eat it?
No. Yeah. I mean, you can.
Yes. Now you can't drink very well, but you can eat. So what happens is it's not gravity that makes your food go from your mouth to your stomach. It's peristalsis that happens, and what it does is it squeezes right above that food and it pushes it out, almost like you're milking your throat. Does that make sense? Y'all know how to milk a cow? Y'all ever seen how to milk? You squeeze up top and then you pull down, and it squeezes the milk that's in the udder out. It's milking your food. That's kind of a weird way of thinking about it. But it's called peristalsis or peristalsis, and it's actually moving, almost like the sides of your throat are doing the worm, and they're squeezing it down. That's why you can eat upside down. So, all right, go ahead and take notes on those three. All right, so talking about a voluntary muscle. Go ahead and tilt your screens down. Voluntary muscles. So voluntary, if you'll read up there, let's go to read. It says the definition is muscles you can control. So what do you think involuntary is without even reading it? It's muscles you can't control. You generally don't control. So can you, if I were to give you some of this hibiscus tea that we're going to drink, and I said, after everybody drank it, I said, haha, it's poisoned. You're all going to turn into a llama. And you were like, oh, no, stop, stomach, stop. Can you stop? Can you make your stomach stop digesting that liquid?
If you stab it.
Now, you can throw it up. You can even force yourself to throw it. You can even take some medicine that will kind of absorb some of the toxins, a lot of toxins, like charcoal or something. But you can't make your stomach stop doing what it normally does. That's not a voluntary muscle. In the same sense, if I was sitting here and I accidentally, or I'm using air quotes, accidentally, if I just, while I was walking around and I just went, whap, and I slapped you guys, and I was like, I am so sorry, my arm just does that sometimes. Would that be believable? No, that's not believable at all, because my arm is a voluntary muscle. I tell my arm what to do. And other times you can get muscle twitches or something like that, but that's not your muscle, your whole muscle. That's an area, like some of the tissue within that muscle that's doing that. So voluntary muscles, They're generally, you think about these things as skeletal, the skeletal muscles. Oh, sorry. You've got skeletal muscles. Some examples of those are biceps or quadriceps. Y'all know those. Muscles in your legs, muscles in your arms, muscles that are connected to your bones. Those are voluntary muscles. Some examples of involuntary muscles are going to be can you stop your heart? Can you make your heart stop? Like, say, heart, stop. No, if you get bit by a snake and you know that your heart is pumping blood, pumping that toxin throughout your body, you can't tell your heart to stop. You can't, let's think about with smooth muscles. Now, here's the thing. With some smooth muscles, you can gain the ability to stop them. But in general, it's more of a stop. So like the smooth muscle that we talked about that's going to stop urine or feces from coming out of you, you can control that. Even what is this muscle here that helps you breathe? What's it called? Starts with a D. Diaphragm. Your diaphragm, you can control that. Now, generally, are you constantly having to say breathe? Breathe. 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 No. There's an old joke that I remember hearing that there was a person, a person that had passed away. Well, let's just say they passed out. This person had passed out, and the doctor came by and couldn't figure out what had happened. And he put the headphones that she was wearing on, and listened. And apparently, the headphones had been saying, "Breathe in, breathe out, breathe in, breathe out." And this person, when they took when they took the headphones off, they stopped listening to it and they couldn't remember what to do. Does that sound reasonable at all? That you could die because you forgot to breathe. In fact, if you hold your breath long enough and you pass out, or for some reason your brain starts losing a little bit of its losing some of its oxygen, it's not getting oxygen, then your body will actually make you pass out. And it's your body's way of saying, "All right, dummy, you're not going to breathe." Like if you were to hold your breath until you pass out, your body says, "All right, dummy, you're not going to breathe. We're going to make you breathe." And so it makes you go unconscious, so your body will take over and start breathing again. And guys, that is a dangerous thing. Remember, you only have so many brain cells. If you start, and the brain cells don't reproduce, they don't go through mitosis like your skin cells do, or your muscle cells do. So you lose brain cells, you're done. Like not you, but those brain cells. Those brain cells very, very, very rarely ever do those things come back. And it can take a lot of work and a lot of medicine to that. So we got voluntary muscle and involuntary muscle. And right here's a picture of the biceps. You've got your bicep here, and it's attached to this bone. What is this area right here? What is this material? This is your tendon. Yeah, and there's some tendons up there. You see there are muscles attached to bones. And if you'll notice, if you go to lift your arm up, your bicep is contracting. If you extend your arm down, this muscle on the back here, what is this muscle? Y'all know? Your tricep is contracting. Your muscles never push. They can only pull. So if you're moving your arm back and forth, you're not using just one muscle, you're using multiple muscles. You're using multiple muscles. So to squat down is a set of muscles that's pulling, and then to sit up, to stand up is pulling. There's multiple muscles that are involved in movement. So if you can see that right there. If you bend your arm, your bicep tightens, it contracts. We've used that word before. Contracts. If your arm extends, then your bicep is relaxing, and your tricep is flexing. So if you want to show your tricep, you put your arm back, and it's this muscle that's on the back. If you want to show your bicep, or what you have, what's left of it, right? What you've actually worked out is going to be you bending your arm up, kind of like your hand touching your shoulder. Sometimes the biceps can get so big that people can't. I had a friend, he could not scratch his shoulder. His bicep was too big. Have y'all seen that video that's gone around online? A smaller guy that took something sticky and put it on this bodybuilder's back, and he could not get to it because his muscles were so big. He could not reach around. Yes, yeah. So here are the three types. Again, that's what they look like. It's not just that they're in different places; they actually function differently. So your cardiac muscle up at the top, your cardiac muscle is going to have to be a different type of muscle than what's in your arm. You just saw that just a little bit ago by squeezing your hand. It's a very different type of muscle. It's similar, but it's a different type because it can go long term. Then you've got smooth muscle. That's also a different type. Those lines that look like zebra stripes, Those are called striations. So it's called striated muscle. Have y'all ever noticed how, like, real chicken, if you eat real chicken nuggets from like Chick-fil-A versus some other places, real chicken nuggets, when you pull them apart, they should be stringy, right? Do you know what I'm talking about? Almost like string cheese. If you pull them apart, you should be able to see strings in them. If you see air pockets, then that means that the chicken was ground up and then made into whatever shapes. If your chicken is in the shape of a dinosaur, it's probably not natural like that. They've made it that way. And it's very likely to be smooth muscle. So things like hot dogs, a lot of times they're made of smooth muscle. Do you understand that? Steak would be made of skeletal muscle. And you can even eat hearts. You can eat hearts of animals like deer heart or quail hearts and stuff like that. Yeah, so striated muscle. Any questions? All right, smooth muscle, cardiac, skeletal. If you wanted to look back, you can look at these. They form differently. They talk about voluntary versus involuntary, and then next we'll go to the skeletal system. So go ahead and take whatever. Go and finish your notes, what voluntary is and involuntary. Finish slide number 10, and then you can be done.